So, a vertical or a slant asymptote is a vertical or slant line of a graph. In this case, the function will get close to it, but you cannot touch a vertical asymptote or a slant asymptote. Okay, you can't touch them. It's not part of the graph. Some of your calculators will kind of put a line in there, but it's actually an invisible line that we represent with dotted lines when we end up sketching these things. These are called non-removable discontinuities. Okay, we can't fix them with just one little point. It's non-removable because it's not just like one point has been removed from the graph. It's a bigger issue than one single point. Okay, so vertical asymptotes come from dividing by zero. Okay, it's not 0 over 0, but it's just dividing by 0 is a vertical asymptote. So you take your denominator after you simplify. So that's why we've kind of done this in this order. We start with horizontal asymptotes. That should be the first thing you look for. Then you factor and look for holes. Then after you simplify it, you look for vertical asymptotes. So you set the denominator after you've simplified equal to 0 and solve for x. These are also errors, so like I was saying, you got to know the difference between the two because both holes and vertical asymptotes show up as errors. Okay, so let's look at this example. X over x cubed minus 4x. What's our horizontal asymptote? Y equals 0. Okay, the degree of the denominator is bigger than the degree in the numerator, so it's y equals 0. All right, so next step, we need to factor if possible. Numerator, not factorable. Bottom is. Take out an x first, and then let's go ahead and knock this out. Let's factor it fully. X plus 2 times x minus 2. Okay, so we can cancel an x. So here's our simplified version, 1 over x plus 2 times x minus 2. So we canceled an x, so our whole is x equals 0. Let's plug 0 into the simplified version. So we get 1 over 2 times negative 2, which is negative 1/4. So our whole is 0, negative 1/4. I want you to write it as a point. Every time, write it as a point. Okay? And then vertical asymptotes, we take what's left in the denominator and we set it equal to 0 if possible, okay? It is possible that we may not be able to set what's left in the denominator equal to 0. If that had been a plus in the bottom, if that had been a plus instead of a minus, we would have had x squared plus 4. X squared plus 4 will never equal 0, okay? X squared plus 4 will never equal 0, so you wouldn't have a vertical asymptote in that case. But in this case, we actually have 2. We've got one at negative 2, and we have one at positive 2. Now, these are typically easier to remember to write as an equation of a line because you're solving an equation, so your x equals is already there, but you have to write, just like the horizontal asymptotes have to be y equals, your vertical asymptotes need to be x equals. Because it's a vertical line. Vertical lines are x equals. Let's look at the graph of this one just so you know how to confirm this. Okay, let's look at x over x cubed minus 4x. Okay, and I'm going to go ahead and put my simplified version in here as well, just so that I can see the difference between my holes and my vertical asymptotes. Well, I only have one hole, but y'all know what I mean. Okay, so here's the graph. All right, so it looks kind of tiny, but if we look at it, here's what I was talking about. My calculator puts them in there. See that kind of vertical line part of this graph? That's not actually part of the graph. Let me adjust my window here so you can see that a little bit better. Maybe make my y's smaller. I'll make my x's smaller too. Okay, so you can see this a little bit better. Okay, you can see the vertical line there more clearly. That is not actually a part of the graph. I hate that it graphs that on there. Really all you should see are these curves. Okay, this one has 3 pieces. Most rational expressions or functions have 2, but it's not unusual to have 3 either. So again, doesn't look like anything weird's happening at 0 where our hole is, but if we go to the table, we can see at 0, we have an error. Okay, this y1 is my original problem. y2, I have a value, negative 0.25. That's negative 1/4. So this is really a good practice to be in, is put your original in y1, your simplified version in y2, because it shows you that's a hole. If it's an error in both, then it's a vertical asymptote. Okay? If it's still an error in the simplified version, then it's a vertical asymptote. Okay? All right, let's look at another one. X squared plus 3x plus 2 over x minus 1. X squared plus 3x plus 2 over x minus 1. So do we have a horizontal asymptote? No, no horizontal asymptote because the degree of the numerator is bigger than the degree of the denominator. So we need to factor x plus 2 times x plus 1 over x minus 1. Do we have any holes? No, nothing cancels. Nothing cancels. It's really close, but not exactly. Okay, nothing cancels. All right, let's see here. So vertical asymptote, we set what's left in the denominator equal to 0. So x minus 1 equal to 0. Add 1 to both sides. X equals 1. I don't know why my x looks so weird there. X equals 1 is our vertical asymptote. Okay? So vertical asymptote should be pretty easy to fill in on our worksheet because you have already factored everything. So